Hello. Today we start discussing models with several explanatory variables. On this slide you can see an example of such a model. As usual, y stands for the dependent or explained variable, and x1 and x2 stand for independent variables. So before we proceed to discussing how coefficients should be interpreted in the model with several variables and in general, we shall first discuss the notion of partial derivative. So we assume that f is the function of several independent variables, namely x, y, and z. If we assume that y and z are constant and we calculate the derivative, then we obtain a partial derivative of f with respect to x. It basically shows you by how many units f will change if x increases by 1 unit. It's important to keep in mind that in this case we assume that y and z are constant. So now we can get back to the model with several explanatory variables, and you can easily see that beta 1 is just derivative of y with respect to x1, because if we assume that x2 is constant, then the derivative of this term is equal to 0, because derivative of a constant is always equal to 0. Analogously, beta 2 will stand for the partial derivative of y with respect to x2. Beta 1 tells you by how many units the dependent variable y will change if x1 increases by 1 unit. Beta 2 tells you by how many units the dependent variable y will change if x2 increases by 1 unit. In both cases, we have to add ceteris paribus. So this Latin phrase just means that we assume that rest of factors remain unchanged. Beta 1 tells you by how many units y will change if x1 increases by 1 unit, assuming that x2 is constant, and vice versa. When we interpret coefficients, it's always units of dependent variable by units of the independent or explanatory variable. In the example of regression model output presented on this slide, the coefficient of GDP in period minus t is equal to 0.11. In this regression model, we examine how GDP growth in period t, let's say in 2020, depends on the value of GDP in period t minus 1, let's say in 2019, in the previous period. In this case, GDP is measured in billions of US dollars, and GDP growth is measured in percentage points. So based on the output, we can say that if GDP in period t minus 1 increases by 1 billion of US dollars, then GDP growth in the next period will increase by 0.1 percentage points. Please pay attention to the fact I said percentage points, not percent, and I will try to explain the difference. Imagine that in the first period unemployment rate is equal to 20%. And in the second period, unemployment rate is equal to 30%. Unemployment rate increased by 50%, by half of its initial value. At the same time, it increased by 10 percentage points. So that's why when you interpret the results of regression model linear in parameters and variables, and if some of your variables is expressed as percentage, in interpretation you use percentage points, not percent. When it comes to other functional forms, for instance log linear model, the interpretation will be different, but please don't worry about this at this point. When we proceed to other functional forms of regression models, linear in parameters but not in variables, I will explain how you interpret the output. Now let us express GDP in millions of US dollars. So billions of US dollars can be expressed as millions multiplied by 1000. And this is the coefficient we obtained from the regression. However, if you want to express GDP in millions, then you will have to divide both sides by 1000 and you will obtain this coefficient. It does not change anything. So if you look at this example, you will see that those two statements are identical. Increase by 1 billion results in 0.11 percentage points increase, and increase by 1 million results by 0.00011 percentage points increase. Again, it makes no difference, but personally I just think that this way of presenting the results is more convenient, because human mind might have some difficulties with interpreting this parameter, this coefficient, while this one is shorter and that's why easier to interpret. We can consider another example. So this is an output of a regression model where Gini coefficient stands for the dependent variable, and GDP per capita and literacy rate, the percentage of adult population being able to read and write, stand for independent variables. So now we shall interpret those coefficients. GDP per capita has a negative coefficient, and it is expressed in US dollars. So if GDP per capita increases by $1, Gini coefficient decreases by 0.00034 here. If literacy rate increases by 1 percentage point, again please pay attention, not percent, percentage point, Gini coefficient increases by approximately 0.14. I do not add any units for Gini coefficient because it's just index. And please remember that in both cases we keep in mind this ceteris paribus assumption. I am able to analyze the effect of GDP per capita on Gini coefficient as long as I assume that the value of literacy rate is fixed. And vice versa. I am able to interpret the coefficient of literacy rate as long as I assume that the value of GDP per capita is constant. So since we are discussing several independent variables being included into one regression model, you might wonder how many variables, independent variables, you include. Technically speaking, hypothetically, you should include all the factors which might potentially determine the value of the dependent variable. It's not that easy, however. Sometimes it's just impossible. Sometimes you do not have enough data. But even if you have enough data and you start to think about all the potential determinants, it might be very complicated. We can think about economic growth. So GDP growth rate depends on capital stock. How many units of capital equipment the economy disposes. Stock of labor, how many workers. Human capital, how intelligent, smart, and skilled those workers are. Institutions. Institutions describe all the formal and informal constraints which determine the way in which society functions. Basically, those are rules of behavior for the people. So it can include democracy, like how democratic the government is, credibility of commitment, like how good the legal system is, whether it's possible to control reinforcement of contracts, and so on. Climate, how good the country is for agricultural production, quality of governance, investment in infrastructure, technologies, and so on and so forth. So those are just the most common determinants of economic growth, but you can think about maybe not hundreds, but for sure dozens of potential factors. So the rule of thumb says that you shall concentrate on the variables frequently discussed in the literature. That's why, by the way, any econometric study shall be preceded by the careful analysis of prior studies. What variables other authors, scholars, researchers used in their models. So thanks to this, you can also pick the range of independent variables. So that was it when it comes to the general introduction to models with several independent variables. I hope you enjoyed this video and see you in the next one.